Alrighty, we're in Unit 5, Video 7, x on both sides of the equation. So we're actually getting close to the end of this point. By now, the math we're learning, the equations we're solving, are really, really close to the kinds of stuff you're going to need in Part 2, but also geometry and all of your future math classes, including Algebra 2 and higher. So this is really foundational stuff. We're going to change our perspective a little bit on how equations work. But before we start, I want to take a little bit of time to just try something a little bit different out. So we've learned a lot so far in this unit. The section is pretty close to pulling everything together at this point. Before diving into the end game of this unit, we need to be confident with a small change in how we normally solve equations. Can you solve these four questions below? Now we flipped the numbers, so the answer is on the left side and the x is on the right. Now I want you to try it out. Go slowly, pause, and in a few moments I'll go ahead and explain these questions through for you. But for now, pause and try them on your own. Okay, so it might have been a little weird trying to solve these questions, but I promise it's the exact same process, just the numbers on the left now, not the right. So first we add 2 on the first one to both sides, just like we did before. That cancels out our plus 2. We're left with a 12 on the left, x on the right. X equals 12. Easy, right? Same thing as before. Here, on number 2, we still divide by 3 like we normally do, and find that 12 divided by 3 is 4. We still have our x minus 5. We add 5 to both sides, and find that 9 equals x. Same process as before, just numbers are flipped. Number 3 is one I think might have troubled some people, because it looks exactly like this one. Just the numbers are flipped. We do it. We add 2 to both sides, and then we subtract, and we have x equals our number. Actually, no. This is like one of the misconceptions we did before. To get the x by itself, we have to subtract 2 from both sides, because our 2 is positive. So, we have 4 on the left equals negative x. Then we move our sign over, and have negative 4 equals x. Now the last one, we have tricky stuff with fractions, but I promise again, it's still the same process. We start by subtracting 2 from both sides. We have 6 equals 3 over 4x. We divide by 3/4 to get rid of it. Scratch out our fraction. And we divide by 3/4 on the other side as well. By doing that, we're multiplying by 4 over 3 equals x. And then this will simplify out to 8. 8 equals x. Same process as before, just numbers are on the other side. Is there anything different about these equations? Only that they're flipped. But that doesn't mean we solve them any differently. We don't do anything different. They're just as easy peasy as before. So, now to rearranging terms or just simply moving things around. This is going to be the meat of this section. You're going to be comfortable with moving numbers around in an equation. And it's also kind of a different way to think about how to solve equations in general. So we saw above that it doesn't really matter if x is on the left or the right side of an equation. We still solve by performing the same operations on both sides of the equation. On the front half of these notes, we're going to change perspectives a little bit on what's happening when you operate on both sides. First, an example. Let's draw a bit on how we combined like terms in the previous section. So, this is a big perspective change. We're going to get the exact same result as what we did before, but it might change your view on how equations are solved. So previously, what we would do is we'd subtract 25 from both sides, say that x would be equal to 7. We're actually going to do something a little bit differently now. Instead of just subtracting a number from both sides, we're literally going to move it to the right side of the equation. Now, we're going to move this 25 over to the right, but to get over this wall of the equal sign, we're going to have to flip the sign of the 25. It's going to go from plus 25 to minus 25. And when we do that, it's going to move over to the right side of the equation. So that cancels it out here, and now it's moved to the right. That means I can bring my x down, and I have x equals 32 minus 25. Now 32 minus 25 is just 7, so x equals 7. We do a similar process with subtraction. We move our negative 17 over by making it positive. So we have x equals 2 plus 17, which is 19. When we were subtracting or adding from both sides before, that's the exact same thing we're doing right now, just instead of subtracting from both sides, we're literally moving from one side to another. It's very fluid. There's a lot of motion going on. The negative 17 is literally going to the other side by flipping the sign. Okay, I have one for you to try. I want you to move that 8 to the right by making it negative. Pause and give it a shot. Okay, so what we're going to do, I literally move my 8 over by making it negative, and now it's going to be on the right side. Once you're confident with this, you can combine in the same step. So I'm going to say x equals 12 minus 8, which is 4. So functionally, what we're showing is that we can move terms to the other side by making them opposite. Positive to negative, negative to positive. We don't normally use we don't normally use variables in a single equation, but they're useful in this situation since we can't combine them. I'm going to show that I can move one of my terms over to the right and one of my terms over to the left. First, I'm going to move a term over to the left. I'm going to take this negative 16c and move it to the left side by making it positive. I'm going to move it to the front, and since it's positive, I don't put a sign in front. However, this is a positive 3a, so I'm going to put plus 3a. Now that I've done that, my negative 16c is no longer there, and I'm going to rewrite 16c plus 3a plus 20b equals 13d. Now I'm going to move my 3a to the right. I bring it towards the equal sign, make it negative, and I move it over next to my 13d. That means I can rewrite this as, first I have to cancel out my 3a here. I have 16c plus 20b equals 13d minus 3a. The letters don't really matter in this case. The only reason I put those there is so we cannot combine them. I can't combine my c, my b, my d, or my a, so I'm left to be able to see what happens to these terms every time they move. I want you to do something similar in this checking understanding. I want you to rearrange all those letters so that they are in alphabetical order. That will require you to not only move them across the equal sign by flipping the sign, but also using our combining terms rules to rearrange the terms so that they wind up in alphabetical order. Once you're done, we can flip over to the back. All right. So now that we have moved terms around, we're comfortable with that process. It's time that we actually solve equations this way. So you're presented with an equation that looks something like this. 10x minus 9 equals 3x plus 5. Now, equations like these show up all the time in geometry. I'd say like every day. What do? Well, definitely something like we did on the front, right? You can probably guess from the title of this section that we're going to be moving terms around. You want to move your x's to one side and your constants or numbers to the other. This is really the same process we did last time, Now just going both ways. So what I'm going to do, I'm going to make sure my x's move to the left and my numbers move to the right. I'm going to move my 3x over to the left by making it negative. So now I have negative 3x plus 6x minus 10. Negative 3x plus 6x minus 10 equals negative 4. I'm going to move my 10 to the right by making it positive. That means I end up with, I'll also go ahead and combine my negative 3x and my 6x to have 3x equals negative 4 plus 10. Well, I can combine these two on the right, and I end up with 3x equals 6. And when I divide both sides by 3, I find that x equals 2. What I did again, I moved my x's to the left and my numbers to the right. In doing so, I am able to combine my terms and solve for x, giving me x equals 2. Okay, I want you to try one of these yourself and see if you can get a similar answer. Pause, and I'll show you the answer in a moment. Okay, so after you solve all this out, you should get a value of x equals 85. If you got it, great. If not, let me know. I'm happy to help you through it. So I want to take a moment to emphasize something. This is the first time we've ever added or subtracted a variable term. Notice that when you add or subtract a variable term, the x moves with the number next to it. If we move our 3x across the equation, we're going to get a 3x on the other side. Everything that's attached to that term moves with that term. So you'll find that solving equations is a lot more fluid once you're comfortable with this process. Numbers can easily flow back and forth from side to side just by flipping the sign. And we'll do a few more examples just to wrap this up. So what you'll see here, I have a 2x on the left minus 89 and a negative 7x minus 8 on the right. I want to move my 7x over, make it positive, and I'll end up with 7x plus 2x minus 89. Once I'm comfortable with this, I can do both at the same time. I'm going to move my 89 over, make it plus 89, and cancel it out from the left side. That's going to mean I have 7x plus 2x equals negative 8 plus 89. Then I combine my 7x and my 2x. I end up with 9x equals negative 8 plus 89, 81. Then I can divide both sides by 9, and I find that x equals 9. Once you're comfortable, you don't have to rewrite the number in the middle. You can just move it over to the other side, and you can do both at once. Only do that once you're comfortable. I have two practice I want you to try before we move on to the checking understanding. Try these two problems and see if you get the answers I'll show you in just a moment. Go ahead and pause and try them out. Okay, you should get x equals 3 here and x equals 2 here. See if you got those answers, and if not, check your work. I'm happy to help you. Once you're done, you can move on to the checking understanding. These 5 problems also have some distributive property. You always want to distribute first and then try to solve. So, do the checking understanding and then show me your work to see if you got the correct answers. As always, let me know if you have any questions, and thank you very much. Have a wonderful rest of your day.